Okay, so section 6.7 is going to talk about electronegativity and bond polarity. So really, this tells you how the electrons are shared between the atoms, so what kind of bond forms. So electronegativity is really just the atom's ability to attract shared electrons in a chemical bond. So if you look at this image or figure from your textbook, as you go to the right and down on the periodic table, the electronegativity of atoms increases. Oh, I'm sorry, I said that backwards. If you go down, electronegativity decreases. As you go to the right, electronegativity increases. So fluorine is our most electronegative atom. So the closer it is to being in a stable electron configuration, the more electronegative the atom is. So you can actually find polarity of bonds, which is just the difference in electronegativity values of two atoms, by using these electronegativity values on this table in order to predict the type of chemical bond. So there are three different types of bonds. There is a nonpolar covalent bond. So this means electrons are shared equally between the atoms. There's a polar covalent bond, which means electrons are shared unequally. So one of the atoms is getting more electrons than the other. Then there's the ionic bond, which is the type of bond where electrons are just transferred to the other atom. So you can just subtract differences and compare them to this table to figure out what type of bond it is. So if the electronegativity difference between the two atoms is between 0 and 0.4, then it's a nonpolar covalent bond. If it's between 0.4 and 1.8, then it's a polar covalent bond. And if it's greater than 1.8, then it's an ionic bond. So let's move this table up so that we can refer to it in the next few examples. So I'm going to do these examples right here so we can actually be able to look at this figure of the electronegativity values. Alright, so the first example is going to be a molecule that has oxygen and potassium. So oxygen has an electronegativity value of 3.5, minus potassium has an electronegativity value of 0.8. This gives us a difference of 2.7. Okay, if we compare it to this table, an ionic bond has an electronegativity difference greater than 1.7. So a bond between oxygen and potassium is ionic. Chlorine and arsenic. So chlorine has an electronegativity value of 3.0, minus arsenic is 2.0. That gives us a difference of 1.0. So between 0.4 and 1.8 is polar covalent. Nitrogen and nitrogen. So in this case, nitrogen has 3.0 and nitrogen also has 3.0. So you're subtracting the same thing. So that gives us an overall charge of 0 for electronegativity. Nonpolar covalent, since it's between 0 and 0.4. Right, last example, phosphorus and bromine. Okay, phosphorus has an electronegativity value of 2.1 minus bromine, which has an electronegativity value of 2.8. So we're actually going to end up running bromine first in order to subtract 2.8 minus 2.1. So you look at whichever one's higher, and that will allow you to subtract the two values. So that gives us a difference of 0.7. So 0.7 is between 0.4 and 1.8, which is a polar covalent bond. All right. When you have a polar bond, something called a dipole results from a polar bond due to the separation of charges. Okay, so first example is going to be a bond between carbon and oxygen. If you look back at our electronegativity table, oxygen is more electronegative than carbon. So it contributes more of a negative charge than carbon. So carbon is actually going to have a partially positive charge, which is shown by a delta plus, and oxygen is going to have a delta negative. And this is because oxygen is more electronegative. And we can also show this by drawing an arrow towards the negative charge. So plus at the end tells you that that atom is positive or has a partial positive charge. The arrow points towards the negative charge. So because oxygen is more electronegative, has more of a negative charge compared to the carbon in this molecule. Okay, so in this video, the overall goal is for you to understand what electronegativity is. So it's the atom's ability to attract shared electrons in a chemical bond. You can calculate the electronegativity difference using this figure from your textbook, because each element has an electronegativity value associated with it. So if you subtract between two different atoms, you can find the electronegativity difference. And comparing it to this table, you can figure out what type of bond it is. And you can also look at the electronegativity to predict the separation of charges. So whichever one is more electronegative is going to be more of a negative charge compared to the other atom in the molecule.